Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss about encryption and decryption using OpenSSL in a Spring Boot application. So what we are going to do is we are going to create a Spring Boot application. Then we'll try to see how we can encrypt our API response and then how we can decrypt the encrypted response of that API using OpenSSL. So when I'm telling you that using OpenSSL, it means that with the help of OpenSSL, what we are going to do is we are going to generate the key pairs. So with the help of OpenSSL, we are going to generate private and the public key. And with the help of that key, we'll try to encrypt and decrypt the response of the API that we are going to develop in a Spring Boot application. So this is what we are going to discuss in this video. There are already 3-4 videos on my channel where I have discussed about the simple encryption, decryption, RSA encryption, decryption, and there is also a video on my channel where I have discussed about how you can install the OpenSSL and how you can generate the key pair using some commands in OpenSSL. So everything we have discussed. If you are new to the channel, if you are new to the concept of encryption and decryption, you can watch those videos to get broader understanding of this concept. Here in this video, let me again brief you the introduction. Here in this video, we are going to generate the OpenSSL key pair. With the help of that key pair, we are going to encrypt and decrypt the response of our API that we are going to generate in the Spring Boot. Okay, or you can say that we are going to create an API here in the Spring Boot and we'll try to encrypt some message and then decrypt out the same message using the key pair generated from the OpenSSL. So this is what today's video is agenda. Let's get started. And first of all, let me try to go to the next slide to discuss about the step that we are going to follow here. So there are 2 steps. The first one is to generate the key pairs from the OpenSSL, and second one is to develop the Spring Boot application for encryption and decryption. And we'll try to encrypt out some messages here. Some simple string messages we are going to encrypt and decrypt. Okay. So let's get started. For that, let me try to come out of this application and then go to the IntelliJ. And here, let me tell you that I'm using the IntelliJ Ultimate version. So what you can expect from me is directly I can create a Spring Boot application in IntelliJ itself. If you're not using the IntelliJ Ultimate version, what you can do is you can go to the Spring Start IO, or you can say start.spring.io, this website. You can go there directly and this will open up the same page, and the things that I'm going to do here for creation of this project, you can follow the same things there itself to create your application. And once your application is created, what you can do, you can download the zip file and then unzip that file and open up in the IDE that you're using. So let's get started for that. And here let me try to create the application. So let's say it is Encrypt Decrypt using OpenSSL. Okay, so I'm just creating the project here, but again, first of all, we need to create the key pairs. Okay, so let me try to first create this project and then we'll I'm not going to use the long walk. I'm just going to use the Spring Web, only one dependency. Open it in a new tab and just wait for a few seconds. Once the dependency that we have added will download and all the necessary configuration will be done, we can start doing our development here. So just wait for that. And now I'm going back to the first step, which is trying to generate the key pair from the OpenSSL. So I already have installed the OpenSSL in my system, and if you are not aware how you can install it out, it is a very simple process. How you install the application, the same way you have to install this OpenSSL as well. So there is a .exe file of the OpenSSL. You can browse on the Google. You will get that. Download it simply and then just set the path of its bean to the environment variable. That's it. So this is what you have to do. Now I've just opened the command prompt to check out the OpenSSL version here. So just type the command OpenSSL and then version to see which version of OpenSSL you have installed. So I have this 3.3.0 and that means we have already installed the OpenSSL and this is the version of it. Now we can directly run the commands to generate the key pairs. So before going to generate the key pairs, let me try to create a folder where I will try to keep the key pairs. Okay, so just let me go to the desktop. Here itself, I am going to create the folder where I will try to keep my key pairs. So let's say it is key pairs, OpenSSL key pairs, something like that. Okay, and let me try to come out of this folders, and let's say, okay, so I'm not sure that is there. So what is the location of it? Let me try to open the command prompt here itself. Or what you can do is you can go to this folder itself and then open the command prompt. So you're inside this folder directly. You can run the commands to generate the key pairs here itself. So we are good. Let me try to close this command prompt, and I already have the command noted down here so that we can directly come here and try to reduce our time, right? Directly we can copy paste this command and generate the key pair. So just copy this command. It is OpenSSL gen t key, and the algorithm that we are going to use is RSA. And then when we are going to do a out, that means it will try to see here gen t means generate private key, and algorithm that we are going to use is RSA, and then it will try to generate your private key under this file, which is private_key.pem. Okay, so just copy this command and go to the command prompt and try to paste it out and then just enter. Here you can see your command is created. Sorry, your private key is created. If you go inside this folder, let me open a folder for you. So here you can see that the private key is created here. Now what I need to do is I need to extract out the public key out of this private key. So how you can do that? So there is another command which is OpenSSL RSA -p out pub out, and from private key we are just trying to extract out the public key. So this is the command for that. Copy it out and directly you can paste it here. Don't worry on that. I will provide the commands in the readme file of this repository that we have created. So directly you can go there and try to copy paste and then try to generate the commands, this keys for you. So we are good. Now if you go to the folder again, you will see that both public and the private key are created here. Now let me try to open the public key and private key one by one, and then try to reuse it out. So just open this public key and we are good. So we have the private key and we have the public key. Okay. Just let me close this other tabs. So we have this private key and the public key is ready. Now what we can do is we can start our development here. So the first thing that we are going to do is we are going to create a class that will manage the encryption, and similar way we have a class that will manage the decryption. Okay, and then at the end we'll try to create one API in the controller class. So there would be three classes. One is for encryption, another is for decryption, and the third one is for the API. So just try to go inside the Java source main Java, and then here you can come and right click on it, new, and then Java class. So let's say I'm just going to create a class called Encrypt Manager. Okay, and we are good. Now first thing that we need to do here is we are going to extract out the actual key out of this private and public key that we have generated from the OpenSSL. So we need to extract out the actual key out of this keys that we have generated, and then we have to use that extracted key to encrypt the message. Okay, so for that we need to write a method for encryption. So first of all, let me try to extract out the actual key out of this key that we have generated. So for that, let me try to create let's say here with the help of public key we are going to do the encryption, and then with the help of private key we are going to do the decryption. So first of all, I'm just going to create a variable called public key in the encryption manager. So let me try to do that. Public key, make sure that this public key is coming from the Java security. And let's say this is now public static final. I'm just going to create a public key string, and in that string, I will try to put the public key that we have generated from the OpenSSL. So let's say it is string public key, a string public key OpenSSL, something like that you can say. And there we'll try to put it out. So just come here, try to copy this public key and copy it out, paste it here, and we are good. Make sure that this comes under one line, okay? Otherwise it won't work correctly. So I'm just going to do that. So just remove these things and we are good. Okay, same for the next line, and the two more lines are left. Let me try to do that. So good. Now the last one is small, so don't worry. So we are good. Now what we did is we have put the public key here in this public key OpenSSL string. Okay. Now the next thing that I'm going to do is I'm going to write the method to extract out the actual key out of this public key that we have in the variable called public key OpenSSL. So for that, let me try to write the method here. So let's say it is public void init, like initialize, something like initialize init public key, and we are good. Now I'm just going to initialize the public key that we have created as a variable at line number 7 with the actual key that we'll try to extract out from this public key OpenSSL string. Okay, so how we can extract out the actual public key from this string of OpenSSL? We need to use this encoded key specs. Okay, so for that X509 encoded key specs we are going to use. So create the object of that, and let's say X equal to new. Okay, let me try to maximize this new, and here you have to pass this public key OpenSSL and decode it out. So for that, let me try to call the decode method and pass this public key OpenSSL inside it out. So we are good. Let me try to write the method of decoding. So let's say when we are going to decode it out, it would be public iterate and decode. Let me try to decode the string data and return base64 dot get decoder dot decode, and then pass the data here. So what we are doing is we are creating the object of encoded X509 encoded key specs, and inside that we are calling the decode method. Inside the decode we are passing this string. So this will try to decode out and then pass it in the X509 encoded key specs. Now the next thing is we need to create the object of key factory. Okay, so just create the object of key factory equal to key factory dot get instance, and then we are going to get the instance of RSA because the key that we have generated is using the RSA as algorithm. So for that we need to have this instance as a RSA. Okay, let me try to put this piece of code as well in the try and catch try block. So we have this thing ready. Now this last thing is we need to generate the public key. out of this. So public key, and let's say it is public key, not public key 1. Let's say it is public key, and just try to generate the public key and then pass this X509 encoded key specs here. Okay, so we are good now. Now let me try to see what it is. So just add the clause, catch clause here, and we are good. Now the next thing is we need to initialize this public key that we have above at line number 12, the variable that we have created with this public key that we have generated out of the OpenSSL public key string. Okay, so let me try to do that. So this dot public key equal to the public key. Okay, so we are good. Let me try to again tell you the whole flow that we are doing here. So first of all, what we did is we have created one public key variable, and it is empty as of now. Then we created one string called public key OpenSSL string. In that we are putting the key that we have generated from the OpenSSL, public key that we have generated from the OpenSSL, and then we are going to extract out the actual key out of this string. So for that we have created one method called init public key, and this is using X509 encoded key specs to generate out the public key out of it. So we have the public key generated, and then we are assigning that to the variable that we have created. So we are good. Now the next thing is we need to do the encoding here. Encryption here. So for that we have the method, like we need to write the method. So let's say we are going to write the method called public string encrypt, and inside that we need to pass the message that we want to encrypt out. So let's say I just want to encrypt the string message here. Okay, now just first of all what we need to do is we need to get the byte array out of this string message. So for that let me try to create the message to byte, message to byte equal to message dot get bytes, and we are good. Now I just going to create the cipher object here. So let's say cipher equal to cipher dot get instance, and in the instance we need to pass the algorithm that we are using. So the algorithm that we are using is RSA. Good. Now the next thing is you need to initialize this cipher with the encrypt mode and the key that we are going to use. So just try to do that. So cipher dot init, and then you need to pass the mode here. So just use cipher dot encrypt mode and the key that you are going to use. So the key that we are going to use for encryption is the public key. Now the next thing is we have encryption done. Now let me try to catch this in the byte array, encrypted bytes, something like that, variable. So just try to do cipher.do final and message to byte. Okay, and now just try to encode it out and then return it. So just I'm going to encode it out in the string format. Okay, so just try to do encode and pass this encrypted byte here. So for encode, let me try to write a encode method, and the same way how we have written the decode method, we need to write the decode method here. So just let's say it is encode, and at the place like this return type would be string, and the value that we are passing here as an argument would be the byte array. Okay, so just byte array, let's say data, and then we have the base64.get encoder, and then encode to a string and then pass the data. We are good. Now we need to throw some exception here, or you can either put it in the try and catch. So let me try to throw it out, and the same goes here. Just throw it out. Either you can do one thing is try to put it in the try and catch, and then catch all these exceptions, and then Yeah, you can do that way, that as well, or you can throw it out. So here I'm throwing it. Okay, so we have written the method to encrypt. In the encrypt method, we are passing the message that we want to encrypt. We are converting that to the byte array. Then we are creating a cipher object and then assigning the algorithm here that we are going to use, and then we are initializing the cipher with encrypt mode and the key that we are going to use for encryption, and then finally encrypting out the message and then encoding it into the string and then sending it out, returning it out. So this is the whole encryption manager is. And again, the same thing we have to do for the decryption manager. So let me try to create a class called decryption manager or decrypt manager. Okay. So here we have created one class called decrypt manager. Now the same thing we have to do here is we have to write the logic for decryption. And the same things, like we have to initialize the private key there in the decryption manager, try to extract out the actual private key from the OpenSSL key that we have generated. So everything we have to do the same way how we are doing here in the encryption. But there in the decryption manager, we have to do the decryption. Okay, so there would be some small changes here and there. So we'll try to manage it out. So what I'm doing is I'm trying to copy paste the whole thing here. So the first thing that we need to do the changes here is we need to generate the private key, not the public key. So just try to generate the private key here. So before that, let me try to refactor this and rename it out. So just refactor, rename, and let's say it is private key. Okay, and this should also be not public key OpenSSL, it should be private key OpenSSL. So just refactor it out, rename it. Let's say, okay, let's say it is private key, not public key. Okay. And here you have to put the private key that you have generated. So let me try to remove this, and later on we'll try to put it there. So don't worry on this. Now again, let me try to rename this piece of code, which is init private key. And again, when you are going to extract out the private key, you don't need to use this X509 encoded key specs. There would be some other encoded specs, which is PKCS8 encoded specs. So this is what we need to use here. So just try to do okay, then we are good. We are decoding out the private key and then passing it out in the key specs. Copy this, pass it here. Okay, before that, we are generating the key factory and then passing the algorithm as a RSA. Now out of this, we are going to generate the private key. So just say this as a private key and then pass the key specs here. Okay, now just change the method to generate private. I'm good. Now what we need to do is we need to pass the private key here to initialize the private key variable that we have created above. Okay, and we are good. And the other thing that we need to do is we need to write the method for decryption. So here what we need to do is we need to write the method for decrypt. Okay, so in decryption what we are going to do is we are trying to let's say pass the message, the string message, and then we don't need to convert it out in the byte array. What we need to do is we need to initialize the cipher with the algorithm, and then the mode would be decrypt mode, and the key that we are going to use is a private key. For decryption we are going to use a private key. Yes, and then what we need to do is we need to do cipher.do final, and then we have to decode it out. So just let me try to do those things here. So let's say it is this 64 dot get decoder, or you can use this get MIM decoder, and then decode your message, and this would be decoded message. decrypted message. And then what you need to do is you need to return this decrypted message as a string. So just trying to do a new string, new string, and then pass this decrypted message. And we are good. Now again, let me try to put the private key here. So just go to your private key, try to copy this private key, and then put it here. Make sure that this is coming in a single line, otherwise it won't work. So that thing you have to do. Okay. So I'm just going to do that, and it will take few seconds of time. If you want to skip it out, you can skip it. Otherwise, yeah, I will try to do those things here. So I will start from the bottom, and or what I can do is I can start from here itself. I just want to minimize the time. That's it. I was not sure why it was not working like this. Yeah, you have to keep it in the same line. You have to remove this extra spaces or / and all, next line and all those things. So just wait for a few seconds. In Windows some part here. Make sure you're doing it correctly, otherwise if any of the keyword is missed, it won't work. So thoroughly you have to do these things, and once it is done, you can try to create the API. Okay, so just we are almost there. Okay, last is left. So we are good now. Now we have the private key. We are like extracting out the actual private key out of this string, and everything look good to me. Now let me try to create the API here. Let's say it is sample controller. So here we have created the controller. Let me try to annotate this with the @REST controller, and then let me try to create one git mapping here. So let's say it is encrypt. Let's say it is sample, or let's say it is git. Simple as that. Okay, now let me try to create a string that we want to, let's say we want to encrypt out. So let's say the simple string, I'm just going to use the channel name. So this is what we are going to encrypt out. Okay. Let me try to put the method name here, public string get, and we are good. And then what we need to do is we need to call this encryption and decryption manager here. So for that, let me try to create the object of them. So let's say we are going to call the encryption manager and create the object of encryption manager, and then just call the encryption manager dot init public key, so that the public key will be assigned to the variable that we have created there. And then let me try to create the object of decrypt manager, and then call the init private key from the decrypt manager. Okay, so we are good. Now what this will do, it will try to extract out the key out of the string that we have put there and assign that to the variable that we have created, or the variable that we are using in the algorithm for encryption and decryption, right? So this is the variable that we are using in encryption and decryption. So it will assign the value after extraction to this. So for that only we are calling those methods. And now once it is done, what we need to do is we need to call the encrypt and decrypt method. So let me try to call the encrypt manager.encrypt method and pass the string here, and then just try to, okay, that will do. And here we need to put this in the either try and catch, or we can throw the exception. So let me try to put it in the try and catch, and let's say once it is encrypted, let me try to print out something here. So let's say once it will be encrypted, it will try to send us a string here. So encrypted a string, and then what I'm going to do is simply trying to print out this encrypted string. So just do that. Once the encryption is done, we are printing it out, and then what we are going to do is we are trying to do the decryption, okay, and do the decryption of encrypted string, okay, and then we are going to print out the decrypted string as well. So just we are good. This is it, and we are good now. Now let me try to run this application and try to hit this API, and then we can see how it is working. And after that, if it is working fine, I will try to give you a summary of the whole thing that we have developed here. So to hit this API, let me try to open the either you can go to the Postman and try to hit it out, or you can directly come here and hit it from the IntelliJ itself. So let me try to hit it from the IntelliJ, and here you can see in the response we are getting 200, and this is the decrypted message that we are getting, which is EnggAdda. This is what we were encrypting it out. Now if you want to see the logs, just go to the run, and then here you will see. So here you can see that this is the encrypted message and this is the decrypted one. And if you want to have a better understanding, what you can do is you can go there to the sample controller, and there itself you can put some additional string here. Okay, so let's say it is encrypted message, and then same thing we have to do here for the decrypted message. Okay, and then print it. So let's say it is decrypted message, and just trying to log the decrypted message. Now let me try to rerun this application and try to hit it out. So we are doing it right, and the encryption and decryption is being done. So we are good now. Now if you want to, either you can hit it from here itself, or again you can go to the browser or go to the Postman, there itself you can hit it out. So we are getting the correct response. Now if you'll go to the run, you will see that encrypted message is this, and decrypted message is again the string that we are encrypting it out, we are getting once we are decrypting the encrypted message. Okay, that means our encryption and decryption is working fine, and we are good at this. Now again, let me try to go to the sample controller and explain you the whole flow. The first thing that we are doing is we have the string that we wanted to encrypt. Now if you want to change out these things, you can do. Let's say we want to encrypt something like YouTube, and then run this application, try to hit the API again, and then see how it is encrypting out the YouTube and decrypting out. So once it is done, our application is up. Just hit this API again and then see in the run. So if you'll go into the run, you will see that this is the encrypted message of YouTube and this is the decrypted out. So the things are working fine. Again, let me try to summarize you the whole thing for you. So here you can see what we did is we have created one controller, and inside that we have one string that we want to encrypt out. Okay, these things you can either pass from the, let's say, as a request body, or you can pass it as a path variable, or you can pass it as a request parameter. Anything is fine. But here for the simplicity, I'm just trying to hard code it out. Okay, everything will be fine. You can use either request body to pass this string from the API again, and or the path variable or the request parameter, anything, you can use it out. Now we have this string that we want to encrypt out. What we are doing is we are trying to call the init public key from the encryption manager and init private key from the decryption manager. What they are doing is they are trying to extract out the public key and the private key respectively from the public key and the private key strings that we have generated from the OpenSSL. These things, right? From them they are wanted to extract out the actual public key and the private key. If you want to see how the actual public key and the private key is looking like, what you can do is you can try to go there to this init private key and try to print out this public key here. Okay, now let me again go to the controller. Once these keys are generated, keys are extracted out, what you can do is you are going to call the encrypt method of the encryption manager and then have the encrypted message and then calling the decrypt manager decrypt method to decrypt out the message and then print it out. Simple as that. If you go to the encrypt manager, what you are going to do here is you are trying to write the logic for the encryption. And if you'll go to the decrypt manager decrypt method, you will find the logic to decrypt it out. All these things I already have covered in the others video, so you can directly go there and try to see how the encryption and decryption are being done. So this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.